Today we will do chapter 12, and this part here, chapter 12, I don't know if you want that to be, maybe I write it in red. Do you want these to be in test 4? At least this chapter here is not as difficult to perform manually compared to the one we have in chapter 4, the linear regression, which is very heavy, calculator work, or even if we want to do it manually, it will be quite heavy. Maybe I put as a poll here. Give me a second. Chapter 12. Let me show you what I'm doing here. Yes, for 4.1 only. No. Please. So should I launch it? How do I launch it? Okay, we have a poll going. You don't need to answer it now. I mean, well, you can, but I will take a look later on before we done for the class. See, I'm really nice, huh? I asked you what you want. Okay, now the thing is, I don't know if this will be in your final. Okay, maybe I mentioned that. Not sure if this will be in your final. I don't know, because there were times that they put it in the final. There are times they didn't put it in the final. There were times they make it optional. Okay, so that's why I teach you anyway. Okay, that's why I teach you anyway. Okay, what is this goodness of fit? We want to test if the frequency distribution follows a certain probability distribution. Now, what will the the change in our template. In our template, it will be, as usual, it will be in our step 2. In our step 2 on the hypothesis, null hypothesis, alternate hypothesis, P1 equals constant 1, P2 equals constant 2, P3 equals constant 3, and so on. Okay, and then the alternate hypothesis basically not equal to, not equal to, not equal to. But this will have the conjunction and this will be or. In other words, either all of these being satisfied or one of them not satisfied. Okay, now then the test statistic, step 3, test statistic will be chi-square of observe. This is an O for observe is equal to the sum of observe minus maybe I don't do that. O is not 0. That's observe minus expected square over expected. Okay, and the way it will be done, they will use chi-square. Well, like what you see here. Now the thing is, they will use right tail chi-square test. Okay. We'll use right tail chi-square test later on. Okay, so here's what I will do. I will do a problem. It's actually not too hard. The procedure is actually not too hard, and it will be even easier once I teach you how to use calculator. Okay, so for the purpose of the final, of course, then I will teach you calculator, how to use calculator. Okay, but I will also teach you how to do it manually, so that you can apply that to Excel when you go to work later on. Okay, now I will explain later on. Why is it that this is not equal sign, but then, well, usually if the alternate hypothesis is not equal, then we do two-tailed tests. That's what usually happens, right? But then why is it the proportion is not equals to a constant, but yet we do a right tail test? Okay, that requires some explanation. But let's do an example first. Suppose, for example, let me pick the question from our textbook. Let me just write it down. Let me pick question from number 8. Number 8. Is it number 8 in my book or no? Let me see. I will just quote it from the book. My bad. Give me a sec. Oh, I don't have chapter 12. Oh shoot! I forgot to post chapter 12. I need to do it later during the break. This is number 8 from 12.1 for that example 1. Example 1. They give us the second step. So step 2, the hypothesis. Maybe I clarify step 1, claim none. Not given. So therefore, we cannot go as far as step 6. Okay, we can go only as far as step 5. Okay, now the null hypothesis, the alternate hypothesis. So the null hypothesis is PA equals to PB equals to PC equals to PD equals to PE equals to 1/5. And alternate hypothesis is at least one of the proportion is different from the others. Okay, now I will do it first. I will do this first, and then I show you later on that the information they give us is actually more than needed. Okay, more than needed. They try to make it easy for us. So step 3, our test statistic is chi-squared observation equals to the sum of, I will write it down, the sum of the mean squared error. Quote unquote, the sum of mean squared error. What is that mean squared error? The observed minus the expected being squared over the expectation. Okay, so this is the squared error, and divided by the expectation will give us the mean in some sense, not exactly the same. Okay, now so here's what I will do. This is observed, this is the observed, this is the expected. Now then I will compute the O minus E underneath here. That will be -2, 5, 1, -7, 3, and then I will square it. This is 4, 25, 1, 49, 9, and then divide by the expected. So this will be 4 over 40. This is 25 over 40. This is 1 over 40. This is 49 over 40. This is 9 over 40. The total will be what's that, 59, 63, 63, that's 88, huh? 88 over 40, that's 2.2. Okay, when I add these, this is 88 over 40. This is 88 here. Okay, this will be 200. The total here should also be 200. So this should be also 200. Now then, we will do the right tail test. So the p-value will be, that's a chi-square distribution. Okay, and we have 2.2. We want to find the area to the right. Okay, we want to find the area to the right. And the degree of freedom is, 4, because there are only 4 categories here. Okay, degree freedom is 4, that's 4 categories. So it will be the p-value will be chi-squared CDF 2.2 E99 degree of freedom 4. Yeah, degree of freedom 4. There are 5 categories, right? 5 categories. And degree of freedom is 5 minus 1. And we use our calculator to compute it. 2.2 4, that's 0.6990, which is a lot larger than 50%, right? Okay, so this will be fail to reject null hypothesis. Formal conclusion, fail to reject null hypothesis. Okay, so basically we don't have enough evidence to suggest that any one of the proportion there is not 1/5. We don't have enough evidence. Okay, now usually this table given to us here, I mean, I personally prefer this table to be given to us in this kind of style. So observe, expected, and then we extend it from there. Okay, so this is category 1, A, B, C, D, E, right? This is category A, B, C, D, E. Now, I prefer to have the table given to us in this format. Now, I said earlier that they actually give us more than enough information there because they want to make life easier for us. So let me show you what I mean. This is 38, 45, 41, 33, 43, and then when we add them, it's supposed to be 200. Now, the information they're supposed to give us actually only this guy here, the yellow one here, and this guy, only those two. Okay, now the expected value here is coming from this 40, this 40, this 40, this 40, this 40. This each of them coming from 1/5 of that 200. 1/5 of that 200. Okay, which will give us 40. So in other words, once they give us the null hypothesis and they say that the proportion here is expected to be 1/5 or 0.2, right? When they say this, then what we can do is we multiply this proportion against the total sample. Okay, so we get 400 there from 1/5 times 200. this 200 here. Okay, that's how we get that 40. Okay, likewise for the rest, when they say the proportion in the null hypothesis is supposed to be 1/5, then the expected value should be 1/5 times the total. Okay, that's how we actually get that second line. Okay, now is our alpha still 0.05? The thing is, they don't tell us. They don't tell us what's the alpha from this question here. Let me check. And because they don't tell us, I just assume that's 5%. Yeah, I'm checking with the book. Yeah, they use alpha. Yeah, they say use alpha 5%. Yeah, but if they don't tell us the alpha, then we basically do it ourselves. Yeah, I assume that's 5%. Okay. Now, how about using calculator? How about using calculator? How about using calculator? We will use, let me use blue color or green color. To use calculator, we go to stat, test. I think it's something with GOV, goodness of fit. Let me grab my calculator. I think this is the test that we don't have in TI-83. Yeah, in TI-83 we don't have this test, but in TI-84 we do. Okay, you will go to I'm sorry, go to stats, stats, oops, one second, I need to share this. Yeah, start test, and then the chi-square GOV test. The chi-square GOF test. Okay, expected, observe, degree of freedom. So I need to insert these numbers into my one of the lists and another one of the lists. Okay, so my first column later on will go to list 1, let's say, and the expected will go to list 2. Okay, or maybe I call that other list. Let's see what list not being occupied yet. Let me just erase all of them, huh? Stat, clear list. I will delete whatever I have in my list. Clear list 1, list 2, list 3, list 4, list 5. Is it all clear now? Okay. Now I will put in list 1 the observe. Do not reverse that though. I mean, if you reverse that, it's okay, as long as you also reverse that in your test later on. And then I get 40 here, 40 here, 40 here, 40, 40. To stat, test, GOF, test, list. Degree of freedom, I need to change it to 4, and then calculate. Boom. Okay, that's the result from our calculator. I hope you find it to be easy enough. Yeah, of course, then the word problems, the actual word problems may be quite complicated. Let's see our textbook. Let me pick question that require us to use some more thinking. Okay, I will pick question number 12. This question number 12, for some strange reason, was a favorite question for one of the person who usually write the department final. Not exactly the same question, not exactly the same question. But the peanut M&N question was his favorite question. Okay, let's see here. According to the manufacturer of M&M, 12% of peanut M&M should be brown. So this should be 12% here. That's the proportion supposed to be. Okay, and then the yellow one supposed to be 15%. The red one supposed to be 12%. The blue one is 23. The orange one supposed to be 23%, and the green one supposed to be 15%. That's the expected proportion. Okay, that's the proportion supposed to be. Now, then how do we test that the peanut proportion there follows the distribution that they told us? So let's start with, I will start with a nice, good big table. This is the color. That's brown, yellow, red, blue, orange, green. The observed was 53, 66, 38, 96, 88, 59, and I don't know the total. $400. Now then, how about the expected one? Not expectation, but the expected given the proportion. Okay, so this will be 0.12 times 400. That's the expectation is 48. Okay, and then 0.15 times 400. I think that should be 60. Okay, this is the same. This is 60 also there, huh? Right? Because green is supposed to be 15% also. And the red one, the same proportion supposed to be with the brown, so that's 48. This guy is 23%. So that should be 92. This is 92. Okay, the total still has to be 400 though. Now let's do the extension. The observed minus expected later on. And then we go on with observed minus expected squared. I do it by hand here. And then observed minus expected squared over E expected. Okay, then this will be, what is this? This is 5, this is 6, this is negative 10, this is 4, this is negative 4, this is negative 1. The total here is supposed to be 0, by the way. By the way, the total here has to be 0. Just to check. Okay. You can use this to check your computation. To check our computation, this total should be 0. Okay, the total should be 0. Because if any category get extra, then other category will be less. In total, should not be any extra. In total there should not be any difference between observed and expected. Okay, yeah, because we did see here 400 minus 400 should be 0, right? Okay, and that also happens with the category. Okay, let's go here. This is 25. I don't think we need calculator for this, right? For this column here, this is 16, 16, 1, which when I add them, I get 61, 161. That's plus 32, that's 193, 194. And then 194 divided by the expected. It's, oh, sorry, I cannot do that. This will be 25 over 48. This is 36 over 60. This is 100 over 48. 16 over 92. 16 over 92. And 1 over 60. Then we use our calculator to compute that. Okay, I get 3.56866. Okay, so that's what the table is. Okay, let's do the hypothesis testing procedure after that table. So step 1, the claim. Peanut M&Ms follows the distribution stated by M Mars at the proportion for brown is 12%. The proportion of yellow is 15%. Proportion for red is 12%. Proportion for blue is 23%. Proportion for orange is 23%. proportion for green is 15%. Hypothesis. The null hypothesis, P brown is 4%, P yellow is 15%, P proportion for red is 12%, proportion for blue is 23%, proportion for orange is 23%, proportion for green is 15%. I think I need to use the word and here. And then the alternate hypothesis, one of them is not true. At least one of them is not true. Actually, if one of them is not true, you must have at least one other not true. Yeah, because if one proportion increases or decreases, then there must be other proportion increases or decreases also. Actually, one of the main reasons I really quite insist to go this far here is because if you are going to biological science, Dr. Zook once criticized me for not going as far as this section in my stats class, while other teachers go as far as this section, but because they use too much calculator, so the students who learn this goodness of fit still don't know how to apply it there. That's because they do too much calculator. So it's kind of like combination between using a lot of calculators so that we can go far, or at the same time, that will compromise our ability to do it manually and then therefore understand the detail. And I try to actually accommodate both. Okay. Well, anyway, so our step 3, test statistic. Here, so chi-square of that observed will be, as we have done it there, that's 3.56866. That's what we get up there. Okay, and then step 4, p-value. That's chi-squared distribution. We have, well, the thing is the degree of freedom. There are how many categories there? There are 6 categories, so the degree of freedom is 5, so the peak is 5, happens at 5, and the test statistic is here, right? It's 3.56 something. So the area, the area to the right must be more than 50%. Don't you think so? Okay, so I expect this to be more than 50%. But you know what? Don't trust my instinct too much. Our chi-squared CDF 3.56866 E99, degree of freedom 5. So what our calculator say? 3.56866. Yeah, that's 0.61302. Okay, therefore it's much greater than any alpha that you tell me, right? Informal conclusion. Fail to reject null hypothesis. Okay, Now notice that the claim is with the null hypothesis. Notice that the claim is with the null hypothesis. This is the claim, right? That's the claim. Okay, so we will reject or not rejecting the claim. The conclusion. Let's use 5%. At 5% significance level, there is insufficient evidence to reject. I think should be evidence here. Reject the claim that copy paste. Okay. It is there. There is actually some big chance that it's actually not following this proportion. Okay, there's actually some chance. It's just that we don't have any evidence. We don't have enough evidence to claim otherwise. You know, right? Imagine if somebody say that, you know what, Thomas, I think this supposed to be 16% instead, and then this should be 12% instead. Now that may fit it better, right? Okay, I'm talking about this guy. Okay, if you increase this becomes 16% instead of 15%, and this guy here make it 11% instead. Okay, then the mean of squared error, this the chi-square of the test statistic may be lower, right? But at least right now, we don't have enough evidence to suggest that it is not what I say. Okay. Yeah. Now that's the power of status quo. Though. The power of status quo is that it's actually quite difficult for us to prove or to not prove, to suggest otherwise, unless we can come up with an evidence that is strongly, significantly different from what the null hypothesis suggests. Okay, and the test statistic, therefore, seems to be directed in trying to reject null hypothesis. Okay, trying to reject null hypothesis is what the test statistic doing. Now you can try using your calculator to do these questions here. Okay, and check with the GOF test. Okay, should I do that? I think I should. Let me do it. So I will occupy my list 1 and list 2. I will just write it off over. So 66 here, 38 here, 96 here, 88 here, 59 here, and then 48, 60, 48, 92, 60, and then S, GOF, Victory Freedom, I change it to 5. My calculator actually shows 0.6130249, while their calculator shows something else. I think it has something to do with the rounding that I did here. Yeah, it has something to do with the little rounding I did here. You see the one here, right? And it affects this. The one on my calculator show if I use that number, that 5-digit number, I get 0.6130249.145. Well, anyway, that's the 5th decimal place, right? So it doesn't change the 6th decimal place. It changed my 5th decimal place, but it will not change the outcome anyway, so that's fine. That's if I use calculator. And if you can use Excel, try to do that with Excel. Okay. And I guess that's what we do right now. Should we do more? Or this is good enough? Let me take a break then. I think this is good enough. Suggested homework from here. Suggested homework from here will be, I did number 12. You can try number, let's see. What I don't like about this is sometimes the question is too, the question is way too long. Number 16. Where am I going? I think number 16 is an interesting question. Oh no, this is for your homework, huh? Okay, and don't do odd. Let's do odd numbers. Number 15, numbers 15, number 19, and 21. So 4.1, 15, 19, 21. Okay, let's take a break until 9:05. I give myself 15 minutes because I'm going to post the I'm going to post the material from chapter 12. Okay, see you later. We will continue on our 12.2. That's a test for independence and homogeneity of proportions. Test for independence. And homogeneity. Proportions. Oh, by the way, I think I forgot to explain this chi-squared distribution. Why is it that when we are testing if the proportion is not equal to a prescribed proportion, prescribed constant, it's supposed to be two-tailed test if that were one or two proportions, right? But right now, when we have more than two, for example, why do we use chi-square test? What happened is we basically try to see the variance. So suppose this is not true. Suppose the proportion is not what they say. Let's say, suppose the proportion is not 1/5 each, for example, then what will happen is the variance will blow up, will increase, right? Okay, so we compare to the observed value with what we expect if the proportion were true. Okay, and therefore from there we see the error, the squared error, and then the mean squared error. Okay, now the mean squared error will be very, very big if any one of these proportion were not true. Okay, so it's kind of like a little sidekick, if you want to call that a little sidekick. If we want to check if somebody's claim is true or not, then you check what we expect. If that claim is true, compare that with the observed and see how big the variance. If the variance is small enough, then we don't have any evidence to say that person's claim is wrong. But the variance is big, then we can question what they claim. Now, in 12.2, we actually extend the idea of that test goodness of fit test into test for independence. Now, I will first show you the calculator part. Okay, basically later on we will input the following. Later on we will have a table, which we usually call contingency table. You'll have contingency table. Okay, instead of only category and observe, we will have, let's say, some columns and some rows. Let's say we have, for example, 2 rows and 3 columns. 2 rows and 3 columns. Okay, 2 rows and 3 columns. Now I will do the following. The one on the top, let's say just for example, let's say this is female and male and come to school by car, by bus, and by other. Okay, now then on the top we will put the observed, and then the second one here will put the expected. Okay, and then I will teach you how to use calculator first. Okay, but the way we will set up our table for now will be as the following. The yellow one will be the observed. And the blue one, the second row, will be the expected. Okay. Now, let's say I pick a question from our textbook right away. We will learn how to key in the data first. So let's say we have this. Let's say we have this. For example, Okay, first we will go to matrix menu, highlight edit, and then select matrix A. Okay, and then the yellow one will be this, the observe. Now, after you do the entry, I think we can put B right away. Hold on. Oh, okay. So why it's different from what I know? Hmm. So I go to matrix menu. Matrix is here. This one here. And then A. Okay. Oh, oh. Edit. And it will be what by what? It will be 3 by 2. 3 by. Oh, okay. That's the row first. So 2 by 3. Okay, now then the first row is 87, 74, 87, 87, enter, and then 74, enter, 34, enter, 12, enter, 32, enter, 80, enter. Second, quit. So it's already in there. Okay, let's put the expected. This is the expected here. These are the expected. So I go to second matrix again, but this time I added B. Make it 2 by 3. And then 75.12, enter, 80.43, enter, 39.46, enter, 23.88, enter, 25.57, enter, 12.54, enter. Okay, let me quit. I'm already okay. Quit. Now, then I go to stat, test, chi-square test. Observe A, expected B, calculate. Do. Hold on. Hold on. You are not looking at what I... Did I forget to share that? Hold on. Wait, I really thought I did. Okay, this is what I get. Okay, let me share with you again. I really thought I did though. I really thought I did. This is what you're supposed to see earlier. Well, anyway, how to key in the data? Go to second matrix, edit, and then go to that. Okay, you need to change this. The first number here is the number of rows. The second number is the number of columns. So you plug that in, 2, 3, 3, and then enter. Okay, and then it will tell you, you basically key in the data one by one. Okay, now after you're done, let me just redo it again. Okay, let me redo it again. So let's go to matrix. Edit. I want to clear one. I wonder how. Originally, it looks like this. Originally, that's what it looks like. Originally, that's what it looks like. Okay, now then, to change that, I put the number of rows and then the number of columns, and then you key in the numbers. Okay, it will actually guide you though, so pay attention to the position. The top left, 87, the top middle, 74, the top right, 34. It refers to this part here, 87, 74, 34. Okay, and then 12, 32, 18. Once you're done, then you do the matrix B. Oops. Matrix B. And you do likewise. I did that earlier. What did I do? This is my matrix A. I need to delete this. This is it. One second. I get a chat coming in. Edit. Let me click this first. Oh yeah, that's right. So I put the matrix B in already, and then after that you go to stats, test, chi-square, test, and the observed matrix, expected matrix, and expected, boom, that's what I get. Okay, oh, the p-value is very small, huh? The p-value is very small. This means what? It means from here, because the p-value is too small, it's supposed to be 5%, right? Then later on, we'll say in step 5. So in step 5, informal conclusion, we will reject null hypothesis. Okay, so then quote unquote step 6, whatever that means, conclusion. Let me use red color here just to come up to the conclusion that the distribution, so whatever we have x and y not independent, x and y not independent. Okay, that's the notation for perpendicular, but you cross it out to say it's not independent. That's just my notation though. But of course, later on, we need to give a more formal conclusion. Okay, more formal conclusion. Okay. Now, let me do one last example for this semester, I should say. One last example. Let me pick a problem that is really what did I do? A problem that is from this is chapter 13. Why I get to chapter 13? Let me do chapter 10. I mean, number 10. I hope I have enough time though. This is number 10. And in our textbook. Okay, does amount of education play a role in the healthiness of an individual? The following data represent level of health and the highest degree earned for a random sample of individuals from general social survey. We have this data here. What will be the degree of freedom, Thomas, if I do it by hand? The degree of freedom will be the number of rows minus 1 times the number of columns minus 1. So in this case, the number of rows, we have 5 rows. The number of columns, 4. So the degree of freedom will be 4 times 3, degree of freedom is 12. Okay, now the number we have here is quite big, so let me use Excel instead to do this, to show you how to do it by hand. Okay. To show you how to do it by hand, which is not really by hand because I use Excel. But I use Excel especially because the computation is too tedious to do by hand, such that I'd rather use some software, but at the same time you can see the detail. Okay, so the one here will be the one here less than high school. College, bachelor. By the way, is that what you see? This is what I want to show. This is what I want to show. And then enlarge that. The health will be excellent, good, fair, poor. I will key in all the numbers: 72, 465, 80, 8.9, 130, 877, 138, 276, 107. Okay, let's focus on this cell. Our goal is to show if we want to show that the level of education has nothing to do with your health. In other words, it will be independent of your health. So your level of education does not. That's the hypothesis. Okay, that's the null hypothesis that it's independent. So if whatever your level of education, it doesn't really tell your if your health is good or excellent or poor, and vice versa. Neither one is a good predictor of the other. Now, how to show that? If that were true, that they are independent, then it must satisfy the situation that I wonder if you remember that the probability of A and B should be equal to probability of A times probability of B. Do you remember that principle? If two events are independent, then probability of the intersections equals to the product of the probabilities. Of course, the other statement is probability of A given B is equal to probability of A regardless we know B or not. Likewise, probability of B given A is equal to probability of B regardless we know A or not. So either one of these, actually once one of them satisfied, all three are satisfied. And based on this principle, we will find the expected number of people, uh, in each of this entry here, if that were true. So what I will do is the following. I will do this. I will do the sum here. The sum here. Now, then this is the observed. Right? This is the observed. Now, I will do the following. I will do the expected here, but this column, this entry here, I will make it empty. Okay. What am I doing? Oh, okay. Let me copy that first. That's not what I want. Copy and then paste it as value. Okay, so this is values right now. I will delete this. Okay. Now, then this entry here will be equal to this guy times this guy over this guy. Okay, think about it first. And the entry here will be this column times that row divided by the total. So these are the expected value for high school with excellent health. And I do it so on and so forth. Okay, if you know how to do the coding with Excel, that would be really great, so that you can just do copy paste. I try to do it slowly right now. I'm kind of lazy to type it one by one again. So how do I do this? Get rid of order first. Need to know some Excel to do what I do here. I can do it a lot faster with other type of coding. That's why please get to know Excel. Okay, it helps a lot in statistics. Okay, then this is my expected. Now then, from here, if you want to go back to your calculator, then you plug this in. Okay, but so if independence assume, then the expected table will be like that. Okay, now let's go on further. Remember the O minus E squared thing and then taken over E. Remember that? Now that's what I'm about to do. Okay, that's what I'm about to do. So here's the thing. That's equal to the observed minus the corresponding expected square divided by the expected. Okay, and then what I will do is I will copy that so you will see that this cell, for example, here is coming from, it's coming from C4, this guy, minus this guy, whatever the difference you square, and then divide it by this guy. Okay, now then I will get the sum. This is our chi-square. This is our chi-square. Okay, let me type what I did here. This is O minus E square over E. Now that's our test statistic. Okay, let me copy this. And put it in our notes. Okay, so from this data here, okay, and then I construct using my Excel to help. I get this guy. Now then, does the evidence suggest that the health and education are related? Instead, so when we say they are related, means they are not independent. are related means not independent. At least the higher your education level, the more you know how to take care of yourself. Okay. To be honest with you, well, I didn't purposely pick this question for that reason, though, but I want you to realize that part of your education is actually not only passing these classes, though. Part of your education is really about, of course, discipline. Part of that is time management. Part of that really self-care, right? Like you need to know when to have your lunch, when to rest, when to study, how much you need to study, okay? And then also on your health care, take care of your health. Nobody wants to get sick, it is true, okay? But you cannot then say, I mean, it's kind of like ridiculous when I hear people say, Thomas, nobody wants to get sick. I didn't want to get sick, but I get sick anyway. Then who should you blame when you get sick? Suppose that we have to, like if you being sick has no consequence, then we don't need to blame anybody. We don't need to find what's wrong with you being sick, right? But the thing is, when you get sick, when I get sick, there's a consequence. Suppose, for example, the other day I say I take a day off. I was not feeling well. Okay, I basically lost my voice again. With that situation, then how do I? If I just say, well, I didn't want to get sick, and then I just stay there doing nothing, not taking medicine. Of course, I will not teaching right now. It will get a lot worse, right? Okay, so it's not that we try to blame somebody when I try to blame somebody when I get sick. It's more about, okay, who has the responsibility to take care of your health? Who has the responsibility to take care of my health? It's me, myself. Since when healthcare becomes a government's burden instead of mine first? Okay, now I agree that I would like the government actually to have some responsibility in my health, right? Okay, we want government to do their part, but it doesn't mean we don't do our part. No, it's ours first. Okay, and it is actually part of, believe it or not, being alive. That's part of life. Okay, that's life education, and therefore it is part of your education. The good thing about going back to school is that it really pushes you to really be responsible, not only to yourself, but also at least to your professor, right? Okay, being responsible to your college, being responsible to the rules that being developed there for us to actually perform well. Instead of thinking of that as rules, actually see that as the guidelines that, okay, for you to do well in class, you need to attend the class. Okay, I know I don't require to uh, uh, go online synchronously with me, but I wonder those people who don't go online synchronously with me, do they even watch the recording that I provide? That's another issue. Okay, so yeah, I want to say that it's not independent. Okay, but of course, what I say right now, if I don't support that with numbers, with statistic, what I say means nothing, right? So what we do right now is, well, you know what? I want to show that health and education are related. Okay, I'm not sure if these numbers actually are real numbers, but I hope it also gives you a hope that the higher your education, the more likely you get healthy. And trust me, education really changed the trajectory of my family tree. Okay, I came from very poor family, very poor. Trust me, I came from very poor family, and it gets a lot worse because my dad and my brother have nose cancer. Okay, and I really pushed myself very effing hard to get through my master's. I even have a chance to have 2 years PhD level study. I didn't finish. I didn't have my PhD, but I finished 2 years. And in that 2 years, I studied a lot, and I get this very good job. Because of better job, better income, I have more resource to take care of myself, and of course, therefore my family, even my parents, right? Okay, and so I'm not saying that you are not doing well right now because of your education, because of your income. No. That's not my purpose. My purpose is this: if you think you are in bad shape right now, education is one way out. That's what I'm saying. Okay, education is one way out. If you have better education, you have better chance to get a better pay, better position. Not only better pay, better position. Imagine me, right? I still keep my paycheck. One of very few lucky job, okay, that we can teach online. So I even save my gas right now, and the consequences I save my car insurance. Right, they give me 15% discount right now because I don't drive that much, and I still keep my health care from school. I also keep my pay from school, right? So if you think about it, in my situation, my shape is actually getting better, and I don't need to drive. I have more time to take care of to help my wife taking care of my children. See, right? And that's not the privilege that other people get. But why can I be in this situation? You know, uh, of course, I have in mind that I still help other people with the income I have. I have others, right? But I won't be able to help my fellow neighbors, my friends, who are in not so lucky shape if I myself not in this situation. Okay, instead of the one receiving end, I'm the one actually helping them out. Somebody have to do that, right? Okay, and it's from education. If you think about it, it starts from education, and that education actually just the tip of the iceberg, if you want to say, of all these things, and of course more than this, more than this, at least this, to take care of myself is one of them. Okay, now, so that's the hypothesis that they try. I didn't purposely pick this question for that reason. I just happened to pick. But I think it's quite interesting to see that you will see later on that the result is actually quite good. Okay, yes, they are not. It is not independent. We can say that the higher your education, the more likely you are in better health. So it's kind of like having this situation. We have more in this section. We have more in this section. Okay, the less than high school, you tend to have fair or poor health, and you tend to have excellent or good health when you have bachelor and graduate. Now, of course, it could means the other way around. It is possible that it is because of your health that actually prevent you from doing well at school. That is also possible. So what we are testing here is just independence, but we are not testing causality. Okay, we cannot really tell which caused which one. Okay, we know it has something to do between your health and your education. Okay, now, does the evidence suggest that health and education are related? So let's do the hypothesis testing. So step one, claim health and education are related. Okay, let me put a note here, means not independent. And then step 2, hypothesis. Null hypothesis, alternate hypothesis. The notation, I wonder if I should just use my notation. Yeah, I would just use my notation. Health is independent from education. Health is not independent from education level. Three, test statistic. The chi-square observed is equal to whatever we have there, here. What number is that? 061. 061. So 285061. 285061. And then the p-value, we are testing if the variance is too big, and therefore it deviates too much from the assumption of independence. It's chi-squared. This is 285061. Okay, the p-value is chi-squared CDF 285061 E99, and degree of freedom is row minus 1 times column minus 1, which earlier we found out to be 4 times 3, 12. And remind ourselves how I get that. This is row minus 1 times column minus 1. Number of rows, number of columns. I believe this becomes very, very small because the peak is supposed to be 12. The peak is supposed to be 12. So this is way too far. This is way too far. 5.061 infinity 4. I get 6 times 6.3906 times 10 to the negative 54. Wow, that's super small. That's basically 0. That's basically 0. Now, because of that, the p-value is much, much smaller than whatever alpha you tell me. Reject my hypothesis. And then step 6, conclusion. At 5% significance level, that's from the question, I believe. There is sufficient evidence to suggest that health and education are related. I only answer part A though. I only answer part A. Construct the conditional distribution of health by level of education and draw a bar graph. So basically, for part B, let me just use Excel again. Okay, by health, conditional distribution of health by level of education. So let me go back to my Excel. For testing of independence has the same procedure as testing goodness of fit. Yes, the answer is yes. You will see actually testing for independence, testing goodness of fit, and testing for homogeneity of proportions are all the same. They're all the same procedure. The difference is when we did goodness of fit, there's only one category. There's only one category. Let's go back. Are we looking at the same thing? The difference is, the only difference is that in goodness of fit, then we only have one category, right? One category here, one row, and then many columns, right? Okay, or if you invert the table, that will be one column, many rows. Okay, now for that one column, we have observed and expected. While in test of independence, we did exactly the same thing. We did exactly the same thing, except that we have more than one column and more than one rows. Okay, the numbers I have here is coming from this guy times this guy divided by this guy. But it's actually as the following. Probability of A intersection B equals to the probability of A times probability of B, right? Okay, that's what we expect. I'm trying to tell you how I get that 39. So so what happened is, I'm sorry, not that one, not this, but this. How do I get that? How do I get this? So here the idea is the following. This guy, now probability of A, let's say, is 976 over the total 3513 times probability of B is 535 over 3513. Now this is the probability for this cell. That's the probability for this cell here. Okay, ignore that 72. That's the probability of this cell. So what is the expected value? The expected value is basically n times p. This is the probability. Probability of A intersect B is this. So how about the expected value for that event? The expected value for that event will be n times the probability for that event to happen. The number of trials times the probability of that event to happen. Okay, which is 3513 times 976 over 3513 times 535 over 3513. And you see one of the 3513 cancels. So we get the column total times the row total divided by the grand total. Okay, we can say that the number in the column times the number in the row divided by the number in the total. Okay, that's the expected value for that entry. Okay, that's the expected value for that entry. So if we go back to the question, construct the conditional distribution of health by level of education. So given the level of education, okay, given the level of education, how about the conditional distribution? My time is almost up, but let me finish this up. I go to Excel. Let me copy this here. But this will be my conditional probability. This and put this in as value. Now for the conditional probability, oops, actually I will need to have this guy is equal to 72 is the entry divided by the level of education, you see, right? And so on and so forth. So this will give you the conditional probability based on level of education. Conditional probability for the health condition given the level of education. Okay, that's the, and then from there, if you want to construct the bar graph, go ahead. Should I do that? No, I don't want to. That's too much. Yeah, I can just use this to draw the bar graph though. Can I? That's what it looks like. breaks it up for you right away. With these 4 classes, right? Good, poor, good, excellent, right? And then the 1, 2, 3, 4, 5, I believe refers to the level of education. Okay, this is where I will stop my lecture, and I'm pretty much done with the material for this semester that I want to share with you. Of course, that let's check the poll. Let's check the poll. So we see the poll. Only 3 people votes, and 2 of you say no, not at all. Only 1 say okay, good for quiz or. Well, so it means there's nothing. Yeah, the majority is no. What was the homogeneity test? Basically the same. Homogeneity test means it's homogen, coming from the word homogen, which means if it is homogen, then they must be independent. That's the idea. Homogen means that if it is homogen, then the health condition is the same. The proportion of health condition is the same. Apparently, I lost some connection earlier. I'm sorry. Yes, I think it's still recording, right? Yeah, it's still recording. Okay, so what I already post the file for chapter 12 online, right? Okay, and should I give you suggested homework? I guess no, because you don't want to quiz anyway. So what I plan to do is I will post 1 or maybe 2 all department final in our file, and I will put it in the announcement. Try to take a look at that, and then please ask me questions if any on Monday. Okay, so on Monday I will only answer questions. If nobody asks question, I will go offline. Okay, and on Monday I will not record it because it's just question and answer. And on Tuesday you will have a test 4. Your test 4 will be basically hypothesis testing up to chapter 11. Up to chapter 11. So hypothesis testing for 1 parameter, for 2 parameters, and linear regression. That's for your test 4. Okay, and then on Wednesday next week we'll do a question and answer again. What chapter are those? Test 4. Let me put it here. Test 4 will be chapter 10, chapter 11. This is hypothesis testing on 1 parameter. And this is hypothesis testing on 2 parameters. And then linear regression. Now, there's a chance that I will ask the the goodness of fit test as extra credit. That's 12.1 extra credit. There's a chance. Okay, so hypothesis testing, linear regression, a lot of heavy calculator. Now, if tomorrow I don't post an old department final, please remind me though. Okay, please remind me, because I want you to study not only for your test score, but also for your department final already. Again, this afternoon will be the time I know if I need to use department final or I can use my own final. Okay, now department final, a lot of multiple choice. It also have free response, but the free response part will focus on hypothesis testing. You can say that approximately 1/3 of your final, any for Monday Q&A, I will answer either test score or final, doesn't matter. Yeah, okay. Now let me tell you first the structure of our department final. Our department final consists of 3 parts. The first part is multiple choice, like I think around 30 questions, and then the second part, 3 or 4 questions, 3 or 4 hypothesis testing question, and the third part is on linear regression. This is approximately linear regression. This is approximately 30 points. This is approximately 40 points, and this is approximately 30 points. So you see that they put a very heavy emphasis on hypothesis testing and linear regression. The good thing is for the linear regression part, most of them is actually you just use our calculator, and there are some little questions on your understanding on terminology. For example, when they ask you, what is the residue for this, like that, you know. Okay, I think that's all that I'm 5 minutes over time. Will you do proctoring during the final? Yes, of course. Yeah, I will do proctoring. The department final, if it is, it will be proctored. In fact, because it's department final, I have to proctor it. But it may be delivered using Canvas. So the problem set will not be posted on the assignment, will not be posted like the way I did it before, like I give you the file, you print it out, but you will just do it right on your phone or right on your computer. You basically type it in. Okay, that's for your final though. That's what I know from the last final. So it is possible that it is the same to my test, that you print it out, work it out, and then you scan it. But the last department final in spring, it was actually done online. You know, so what happened is you go online, and then once you open the file, the clock starts right away. Yeah, but no, the good thing is nothing to print out, nothing to scan, right? Okay, and I will need to use something called Proctorio, as I know. Basically, somebody will, I will set it up in a way that there's a, beside me looking at you, there will be a software actually proctor you. Other question? Sure, you're welcome. Okay, that's for today. See you then on Monday.